Okay, we have a question about the tangent plane. Somehow the formula in the book didn't look like what was expected. Yeah, one student said, here's the formula in the book. I like what we did in class. It works better, but it doesn't seem to reconcile with the formula. So just to reconcile that. For a tangent plane, in the xz plane, if you move a unit in the xz plane, how far do you move in the if you move a unit in the x direction, how far do you move in the z direction? Well, it's going to be the slope times the run. If you move a unit in this direction, your rise is just going to be equal to the slope. And the slope is your x derivative. So that the vector I plus fxk is going to be tangent to your plane. And similarly, if you're in the xz plane, you move one unit, you move j, and then you move fy times k. Fy will be the rise of a triangle where you have one unit in the j and some displacement in the k direction. Well, we take the cross product of these two vectors, and let's make the cross look a little more substantial so we understand it is a cross product, although it's probably the only way to interpret it. The cross product is very easily calculated. It's this. I cross k is negative j, so we get negative fyj. K cross j is negative I, so we get negative fxi, and I cross j is k. Now, if we have the point x naught, y naught, f of x naught, y naught, which was the notation in the text, then a vector x minus x naught I plus y minus y naught j plus z minus f of x naught, y naught k is a vector from the point x naught, y naught, f of x naught, y naught to the point x, y, z. Well, that vector, if it's in the plane, has to be perpendicular to the normal. So our condition for the point x, y, z to be on the plane is that the dot product of this normal with this vector has to be 0. Okay? So the dot product, and I just put some dots down here for, the dots don't represent a dot product, but I just said, okay, we're going to skip that step, but the dot product is clearly this, and it's going to be equal to 0 if these two are going to be perpendicular. What two? Where is it? This one and this one. This one and this one. Okay? Now, if we look at this, if we solve this for z, well, this is negative. And of course we have a coefficient of 1 here, so we just remove the parentheses. We just have a z. We add this to both sides, there it is. We add this and this to both sides, there they are. So z is this, and that is exactly, I believe, the formula that the text has. But with reason, okay? And if we understand where this comes from and understand the meaning, none of these steps are particularly difficult, particularly hard to understand. The premise is just that the vector from the x naught, y naught, f of x naught, y naught point to x, y, z is perpendicular to the normal vector. I almost said a wrong word there, okay? And the normal vector, of course, is this. Okay.